Throughout the history of astronomy, one of the biggest questions has always been, where do the building blocks of life come from? Specifically, how does carbon, the essential element for life as we know it, spread across the universe? Well, thanks to NASA's James Webb Space Telescope, we may be closer than ever to uncovering the answer. A groundbreaking discovery involving carbon-rich dust in the Milky Way, 5,000 light-years away, and the incredible process that might just be responsible for seeding stars, planets, and possibly life itself. Deep in the heart of the Milky Way, there's a star system known as Wolf-Rayet 140, where two massive stars are locked in a cosmic dance. These stars are in highly elliptical orbits, meaning every 8 years they pass incredibly close to each other. When their orbits bring them close, their powerful stellar winds crash into each other. This collision compresses the materials in their winds, creating carbon-rich dust particles. This carbon-rich dust doesn't just hang around the stars. It forms into expanding shells that spread out into space, visible in the mid-infrared light spectrum. Webb's ability to see in mid-infrared light allows us to witness the birth of these dust shells in unprecedented detail. And the best part? These shells are moving at astonishing speeds of more than 1,600 miles per second, almost 1% of the speed of light. Incredibly, scientists have already identified 17 distinct shells of carbon dust, each one formed during a close encounter between the stars over the past 130 years. And these shells are expanding at such a rapid pace that scientists can track their movements in real time, something we rarely see in the vast, slow-moving cosmos. These carbon-rich particles come in various forms. Sometimes they form huge amorphous clouds, as large as our entire solar system, and other times they float as individual dust particles. Over time, this dust might eventually play a key role in forming new stars, planets, and possibly even rocky planets capable of supporting life. As for the fate of these stars, it's clear they're approaching the end of their lives. One could go out in a dramatic supernova explosion, while the other may collapse into a black hole. Regardless of the outcome, the carbon dust they've produced might be scattered across space, helping to form new stars and planets far beyond their original home. These discoveries not only shed light on the origins of carbon, but also on the formation of our very own galaxy, stars, and planets. The dust from stars like those in the Wolf-Rayet 140 system could help answer a question that has long intrigued astronomers. Where does all the dust in the universe come from? Thanks for watching. Be sure to like, subscribe, and click the bell icon to stay updated on more incredible discoveries from the James Webb Space Telescope.